All right, in this video, we're going to be going through Chapter 3, Section 5. And we're continuing our work with quadratic functions. But in this section, we're going to be looking at inequalities with those quadratic functions. Okay? So the first thing we want to remember is that we have our standard form, which is ax squared plus bx plus c. But now that we're looking at inequalities, we're going to change this symbol, right? That's an inequality. So we can either have greater than, we can have greater than or equal to, we can have less than, or we can have less than or equal to. So those are going to be our symbols that we're using instead of our equal sign. So one thing that we're looking at is we can always graph these functions. Okay, so where it's above the x-axis, right? So after my 2 points where it's above the x-axis, that's where my f of x is greater than 0. And where it's below the x-axis, that's where it's less than or equal, less than 0. Okay, so we'll get into that in just a little bit too. So here we're going to solve this inequality. So x squared minus 4x minus 12 is less than or equal to 0, and then graph the solution set. So the first thing I want to do is I want to go ahead and graph it. And in order to graph it, I have to find several of my points. So the easiest point to find is that y-intercept. So I set my x equal to 0, and I find that my y-intercept is at a negative 12. I find my x-intercepts, and that's when I factor or use the quadratic formula to find my x values when they were equal to 0. So here we set our function equal to 0, and then we factor it out, and we find our two solutions are at 6 and negative 2. And then, so I have those 3 points. I have my y-intercept, and I have my two x-intercepts. Then I also want to find the vertex. So to find the vertex, I always go my x equals negative b over 2a, and plug in the values that I have from my function up here, and find that the vertex is at 2, negative 16. So now that I have all of those points, I can go ahead and graph it. Let's see if our graph is here. There it is. So I graph my vertex, my y-intercept, and my x-intercepts. So from there, we can analyze what we're looking at. Okay, so I'm looking at something that's less than or equal to 0. So anywhere that we're below the x-axis, so in between these 2 points, let me use a different color, okay, I am below the x-axis. So this is all of my possible solutions. And remember here that it was less than or equal to 0, so I can count these points as well. Okay, so that's one thing we have to keep in mind. So I can also write it several ways, right? My solution set is that negative 2 is less than or equal to x, which is less than or equal to 6, or I can also use my interval notation. So either way will work. So here again is that graph. And we can see down here we've also just graphed the solution set. So when we're just graphing the solution set, here's where I can use my brackets to include the points, and I'm just using my number line to explain the solutions that I have. So here's our next example. So we want to solve this inequality. So 2x squared is less than x plus 10, and then graph our solution set. So there's really 2 ways to do it. The second way is very confusing and a lot more difficult, so I'm going to skip that one. So we're just going to look at this option 1. So we want to rearrange everything so that 0 is on the right side. So I get all of my terms over to the left side. So now I have just my normal inequality. Okay, so I have all of my terms, and it's going to be less than 0. So again, I need to graph this. So I find my y-intercept, so I set x equal to 0. I find my y-intercepts, or my x-intercepts, by setting y equal to 0. Here we can factor it out and apply the zero product property, and I find my two x-intercepts. Then I'm also going to need to find my vertex, right? And to find the vertex, it's always x equals that negative b over 2a. And I find that, and then I plug this back into my equation to find the y value of my vertex. So there's my vertex. So now let's look at our graph. So now that I have those points, I can graph them. I have my two intercepts, I have my vertex, and I have my y-intercept. So I can graph my parabola through those. Okay. So we're looking at below 0 is less than 0. So I know that I do not include 0, or I do not include my intercepts here. So I can write it with just a less than here, or I can again use my interval notation with the parentheses instead of the brackets, right? And again, we know it's less than, so I'm looking for everything below the x-axis. So we're below the x-axis between these 2 points. So then again, I can use my number line. Whoops. I can use my number line to show this as well. So here, since we're not including those points, I go ahead and use that parenthesis instead of a bracket. Okay, and here's our next example. So solve this inequality, x squared plus x plus 1 is greater than 0, and then graph our solution set. So I want to find all those same points. So my y-intercept is 1. So there's no x-intercepts, okay? So that's one thing that will tell us that we're not actually ever touching the x-axis. So here I see I can look at the discriminant. I remember that the discriminant is b squared minus 4ac. So let's try that. So my b is 1 squared minus 4 times a, which is 1, times c, which is 1. So I have 1 squared is 1 minus 4 times 1 times 1 is 4. So this is a negative number. So because I have a negative number as my discriminant, it tells me that I have no real intercepts. I can still find my vertex and some other points, just plugging in some points, and then we can look at our graph. Okay, so here's the graph that we're looking at. What really helps us the most is we don't even have to graph these other points. If we find the vertex and see that the vertex is, we're going to know, above the x-axis here, then I know that all real numbers are going to be a solution, because I'm looking for where this function is greater than 0. So if I look back at my function, I notice there's no x-intercepts, so I know I'm never going to cross the x-axis. I can also look at my a value here, which is positive, which tells me it opens up, so it tells me that it's all above the x-axis. So all real numbers would be my solution set. And that, again, we can write in interval notation, right? And we can also use our number line to show that as well. Okay, so now let's go ahead and look just back at our learning target of solving inequalities using a quadratic function. So to solve these, we have to first graph them. And in order to graph them, we have to find the vertex by using our negative b over 2a. We need to find the y-intercept, and we need to find any x-intercepts. Once we have these points, we can plot them in graph and then determine where in the graph is either above or below the x-axis that we're looking at. So now that we've worked through this learning target, go ahead and work on your homework for this section.